Hi, this is Dr. Nick Bucher at North Seattle Community College, and today we're going to be talking about recrystallization, which is a purification method. Our goal is to take advantage of the fact that solubility varies with temperature and create a very hot, very saturated solution of our impure material. As we cool off the solution, what's going to happen is crystals are going to form, but the impurities will be left behind in the solution. I want to point out this method would ordinarily be conducted in a fume hood, but we're shooting it outside of the fume hood today, so it'll be easier to see for the camera. I've set up a stockpile of solvent on the hot plate to heat it up. I'm using an Erlenmeyer flask because the narrow neck minimizes the amount of evaporation. You want to be sure to add a few boiling chips to the solvent to prevent any bumping or splashing, so the bubbles have a place to form. You'll notice that these hot plates have numbers on the front of them. Unfortunately, these numbers don't have any real meaning. You want to ignore the numbers. Much like when you're cooking on a stove at home, you want to adjust the heat up or down in order to achieve the rate of heating in which you desire. Our solvent is now hot, and we're ready to continue our experiment. I'm going to pour our impure material into a 25 milliliter Erlenmeyer flask. To this flask, I already added a stir bar. The stir bar is going to agitate our solution, as well as provide a surface on which bubbles can form. It's very important that before we add this Erlenmeyer flask to our hot plate, we transfer over some hot solvent. We don't ever want to put this on the hot plate without solvent, because the heat from the hot plate can damage our compound. I'm now going to turn on the stirring. And our goal is to dissolve our compound in the minimum amount of solvent possible. This is going to prove to be a bit of an art. If your compound's not dissolving, just simply add a bit more solvent. And if you add too much solvent, you can allow some of it to evaporate over time. You want to maintain a temperature here where you're right at the edge of boiling. If you're boiling too fast, the solvent evaporates quickly. And if you're below the boiling point, it's hard to judge the temperature. Your temperature might actually be too low. I've continued to transfer solvent into our small Erlenmeyer flask until our compound is completely dissolved. I'm now going to remove it from the heat, set it on a lab notebook, and put an inverted beaker on top of it. We do this to slow the cooling process and maximize the crystal formation. After 5 to 10 minutes of cooling slowly, you'll notice that crystals have begun to form. You might see needles, plates, or a mix of the two. I am now going to transfer our small Erlenmeyer flask to an ice bath I've created in the 150 milliliter beaker. Notice I've used the 150 milliliter beaker because it's too narrow to allow the Erlenmeyer flask to tip over. The ice bath is composed simply of ice and water. The Erlenmeyer will remain in this ice bath for approximately 5 to 10 minutes. Our crystals are now ready to filter. I've set up a Buchner funnel on top of a sidearm flask, and I've connected the sidearm flask to the aspirator on our sink using some thick vacuum tubing. Don't use the thin latex tubing. The thin latex tubing will collapse when you apply the vacuum. Notice that I've also clamped our sidearm flask. It can tip over easily. I highly recommend that you clamp the sidearm flask to prevent it from breaking, tipping over, spilling your sample, etc. It's very important that you add 1 sheet of filter paper to your Buchner funnel. If you fail to do this, your crystals will fall right through into the sidearm flask. I am now going to turn on the aspirator. And I'm going to add a few milliliters of ethanol to moisten our filter paper. I'm going to remove our Erlenmeyer flask from the ice bath, and I'm going to put our solvent in the ice bath to cool it to around 0 degrees. I am now going to pour our crystals into our funnel. And our solvent should begin to filter through, fall through, and our crystals should remain on the filter paper. I'm going to transfer about 2 milliliters of ice cold solvent to our small Erlenmeyer flask to help rinse out the crystals. And I'm now going to repeat. So a total of approximately 4 milliliters of ice cold ethanol will be used to rinse off our flask. We're now going to let the vacuum run for a few minutes until the crystals have begun to air dry. After a couple of minutes of running the aspirator, your crystal should now be somewhat dry. We can remove the top of the Buchner funnel, and it can be stored in your drawer for a few days in order for the drying process to complete. After the drying process is completed, we can test the crystals for purity using the melting point apparatus in the instrument room. I hope you found this tutorial helpful. As always, should questions arise, please ask your lab instructor for help. This is Dr. Nick, signing off.